Question 5, we're going to do this, I think, in 3 separate parts. So this is an example of a weak base, strong acid, which is the opposite of what we did in lesson 21, which was a weak acid, strong base. So we're told that we have a 90 ml solution of a 0.6 molar ammonia with a Kb of this, and it's titrated with 1 molar of HCl. It wants to know what's the pH before any acid is added, so we have to only concern ourselves with the equilibrium that ammonia is experiencing with water. Ammonia is a base, so it's going to accept the proton from water to form the conjugate acid ammonium and hydroxide. We know that we're starting with 0.60 molar, and what we don't know is what we know that we have none of this. It's going to force the reaction to the right and produce the products. Now I'm going to take my Kb, multiply it by 1,000, and we're going to see that this is still less than the 0.6 molar, which means we can ignore the minus x there and just plug this directly into my products over reactants expression to solve for the pH, which will really be the POH. And that's that x is equal to 0.0329 molar. I'm going to take the negative log of that value, and that's going to give me a POH. Let's write that right. POH of 2.48, and to solve for the pH, I'm going to subtract the 2.48 from 14, which gives me a basic pH of 11.52, which makes sense because it's a base and no acid has been added at this point. It wants to know what the equivalence point is necessary to meet equilibrium, or the equivalence point. So we have to think about what type of molarity we have here. So lo and behold, it's 1 to 1. So we can start with our molarity of ammonia, and we know that we have a volume of 0.09 liters of ammonia. It's going to be in a 1 to 1 ratio. And you could break these up into separate steps, but I am a fan of setting up the entire train track all at once because you can have blank spots like we see here. That's fine. It does not have any sort of impact on the final answer as long as you have everything canceling out. So liters of ammonia, moles of HCl. So this is from the molarity. Sorry, I was saying something else whenever I wrote that in, which is from the problem. And in the end, I get a final answer of 0.054 liters of HCl, which is the same as saying 54 milliliters of HCl needed to reach the equivalence point. So remember, in titrations, we tend to use milliliters.